today we're going to talk about data pipeline with Airflow and Google Cloud Platform services such as BigQuery, Cloud Storage, Dataproc, to use it with PySpark. And so let's get to it. So we are going to break the video into like 4 sections, talking about like the data sources, how to get Airflow running in Docker, talk about the pipeline and the project itself, as you can see here in this schema, and then to talk about a little bit about the budget. Good, so let's get to it. So we have a database and a virtual machine running on DigitalOcean. You could find the referral link in the description of the video to get $200 of credits. It's pretty neat. So we have like virtual machine where we have our Airflow running, and we have a Postgres database running here. Which database are we running here? We are running the DVD rental. That is a sample database provided by Postgres tutorial. It's an excellent site to learn about Postgres if you don't know anything about it. And here is the entity relationship model of the database. As you see, there are like 15 tables, as we can see here as well in the database, now that we are connected. Actor, addresses, category, and so on until we store. All of those tables relate to this way. You could see more in the Medium article, or go and Google DVD rental sample database. So that's our data source. What we are going to do, as you see here, is like using Airflow, running on a virtual machine on DigitalOcean, move those tables from the Postgres database to Delta Lake, using Cloud Storage and BigQuery and Dataproc to create PySpark jobs. And that way we could move the data from layer to layer, from raw to quality, quality to access, and so on until we get to the business intelligence layer, where we will create like dashboards and etc. So you maybe are wondering how Airflow is running on a virtual machine. That's pretty easy if you follow the steps provided by Airflow itself, and you could have an Airflow web server running with the workers and the scheduler. So this is the only DAG we have, and you can find that DAG in the repo under the DAGs folder that you can see here. You will see like all the code. Also, the code link will be in the description of the video. So what the DAG does itself is, as you can see here, like generates first a task, a bash task. This one generates a unique identifier to track the logs of each execution. Then it moves all the tables to the raw bucket. As you see here, we are moving. Sorry, let me go back to the article. In the schema, we move like all the tables to the raw bucket. Then we create the tables in BigQuery in the raw data lake. Then we move the tables to the quality layer, then to access layer, and then to stage, and finally to the business layer. And for each one there is like a separate query, and the 4 last tasks use Dataproc to kind of transform the data using PySpark and SQL. All the code for the PySpark jobs, you could find those under the PySpark folder, and you see like naming by the layers that are involved, like moving the row, data from raw to quality, moving the data from quality to access. So that's pretty much how the Airflow DAG works, and itself like the pipeline. So to have like the pipeline running, you will have to set these two different connections. This one is to have access to the database, and this one is to have access to the Google Cloud platform services. So first you will need to, of course, create a project in Google Cloud, then give permissions to the different like participants of the project, and you will need to create an account service that you can do that right here in account service, or as I have it in Spanish, cuenta de servicio. And then when you go there and create like an account service, you can go click here. I have already done it. Then when your account is created, you go to keys, and then you create a new key. This will create like JSON file, and you can go to that connection and create it, and you will need that file here. Also for the Postgres connection, or like any database that you are using, you will need, of course, like the host, the port, the user, the password, and the database to use. In our case, it's the DVD rental database, as we see here, and we can check like any table schema. As you can see here, the actor has the actor ID, the first name, and last update. And of course, as you just saw before, here we have like all the relations between the tables. Also, I will leave you here like a couple of links and YouTube videos to follow the tutorial if you want to replicate this pipeline and get an Airflow running on your local machine, or maybe go to DigitalOcean and use those credits on your own droplet. So now, like focusing on the pipeline, we have, of course, created our project. As I show you how to generate a key for the account service, create like the two connections for the Google Cloud default connection to have access to Google Cloud services. Also the database connection, in my case we are using Postgres, but there are more type of connections for database. And now let's go to the code itself. Let me just open my editor here. So this is the structure of our pipeline. So, and we're going to focus on the DAG. So a lot of imports from Airflow, inputs from providers such as Postgres, Google Cloud, to use like move Google Cloud files to BigQuery, move tables from Postgres to Google Cloud, and the dataproc operators to create a cluster, to delete the cluster, and submit a PySpark job. So bunch of variables as you see here, like the project ID, the naming of the clusters, the bucket for the PySpark scripts, because those need to be in that bucket inside your project, and we have it here in Spark final project, and those 4 files are the same that you will find here. And in a moment you will see like where do you need to specify that location. So just the list of tables, the DAG arguments, which is keeping track of the version because we did like a lot of modifications. We don't need a catch-up description, the owner, like using variables in Airflow, and you can see the variables here. Going to admin variables, I have created these 3 variables: the interval to be daily by default, the message if I want to specify a message, and the owner. So as you can see, when you go to DAX, you see like the owner. So that's the owner that we get, Andres M. The interval is daily, as you see here, and also here in the variables. So let's start with our DAG. So first we create like a bash operator, as I show you, just to check and generate like the entry point for our execution. Then we create a task group to loop all the tables in the source table list. And what it does is just select all columns and all rows from each table using the Postgres connection ID. As you can see here is the DVD rental connection, is the same connection that we have created here in the connection panel. And just like the full arguments that we have in the Postgres Google Cloud Operator. As you see, like we need to specify a unique task ID. That's what I'm concatenating, like the name of the table to the task, and that's what we see here. Like move tables to row. As you see, the only thing that changed is move actor to row bucket, move address. So this part here is like the dynamic part of the code. Yeah, and then we specified which is the bucket where we store the data, if those files are in a specific folder, as you can see here. So let's go back to where we have like the raw data that is here. As we see, there is like one folder for each table, in case maybe that the table is split into several files, or maybe you have like a monthly file or daily file. That could be the case. Yep, so pretty much that's it in this task. Then we have this task group to create the tables in the data lake row. So our data lake is BigQuery. So as you can see here in BigQuery, we have like all the layers: raw, quality, access, staging, and finally business, where we have like all the data. Okay. So as you can see here now, we use like this operator that is called Google Cloud Storage to BigQuery operator. What it allows us is to load Google Cloud Storage files and create a table in BigQuery. We could specify which pattern of objects in that bucket. Maybe we are just interested in CSV files or files that follow like a specific name pattern. I'm just interested in all the files. Using CSV, there is a couple of formats that you could use as well, such as JSON and Parquet. My files have the header in the first row, so I'm going to skip that row. Then, of course, our destination dataset, we need to specify that and then create a table. So the dataset row, as you see here, is like the final project. The project ID dot like the name of the dataset. This name of the dataset, you can see it here, and you can get like this ID from here, and that's the one you copy here. Be sure to create the datasets before. So moving at like more quickly here, now we have like the raw to quality layer, and here in this task group we have to generate like 3 different tasks. Just open it here. As we see, these 4 tasks are pretty similar. We just like create a cluster, then process the data within that cluster, submit in a PySpark job, and then delete the cluster after everything is done, if it succeeded or not, because we need to delete that cluster. If not, that's gonna cost a couple of bucks more. So now we have here, we create the cluster, we are creating the cluster for the raw layer. We specify the project ID, the cluster name, the number of workers. You can increase this, but of course that will spend more. Then you specify in which bucket Dataprop is going to use as a temporary bucket, because you need to store like a couple of files there, as you can see those here. This folder is created by Dataprop because it needs to store a lot of temporary data. So just make sure to create that bucket before. Then we need to specify like the PySpark job. This is the way to do it. Generating this JSON, when we put like the reference with the project ID, the job ID, make sure to concatenate some random number or this UID. Otherwise, if you run this again, let's say the job ID is just raw to quantity, it would fail because that ID will exist, you know. Then the placement is which cluster it is, so that's the cluster that we created before. Then the labels, the Airflow version you are running. As you can see here, we are running 2.4.1. Then specifying the PySpark job. This jar file, your eyes are, you have to specify a list. This one is created by Google. You just look it up in the documentation or just copy and paste this. And then the Python script. So that's, you need to pass like the text with the Google Cloud Storage location of that Python script. So remember that we stored that one in a bucket called Spark Final Project bucket, and the script to execute in this task, that is to move the data from raw to quality, is called that way, like 0_raw to quality.py. You can see that file here, and what it does is just pretty similar that we have done before, just selecting a couple of columns of each table. Then we create like our Spark session, and for each table we load the data from BigQuery. As you can see here, we create like temporary views of each table, and then we could use, after we have that temporary view, we could use this kind of queries, because this table would be a temporary view on Spark tables. So that's the way it works. Then you just call the spark.sql method, and this argument here will call one of each queries, like each time. Then we save like the modifying table. Of course, here you could have like a more complex query, removing like null data. This sample database that we are using is pretty simple and it's pretty clean, so we don't need to do much. And then you can just save it as a table in BigQuery in the target dataset. In our case, it's the quality dataset in BigQuery here. Then just override, because that's the way we want it right now, because you have like more modes, maybe just to append or something, or maybe fail if the table already exists. There are several modes that you could check here: append, override, error if exists, or ignore. So then after we have moved like the tables, as you can see here, like now here we are defining the task, passing it as this PySpark job as an argument. Then we delete the cluster, and here we specify like the dependencies in this task group. That way it follows that specific order: first creating the cluster, then moving the tables, then deleting the cluster. Very important here is to check this trigger rule to all done, not all success, because maybe one of these could fail, and maybe you could have like that cluster running forever, and that will just follow this. This will save you a couple of dollars. And so that's pretty much the same for the other task, just like calling different scripts. The very end, now we have like the dependencies of all tasks and all task groups. So as you can see here, we have a bash operator, and the other ones are task groups, and we can call them here. So first generate the bash tag, then move the tables to the row bucket, then create the tables in the data lake row dataset, then quality, then access, then staging, and then the business layer. And that's pretty much it. Also you have here like the logs file, all of the logs and Airflow like detecting automatically the DAGs. That's because we have created Airflow with Docker, with this Docker file and this Docker compose. You can see here that we have those Airflow dependencies running, such as the scheduler, the web server, and the database running on Postgres. And that's how it works. So at the very end, once we have everything in BigQuery and created in our like business layer, we could go here and create materialized views, create different views, and use these tables as a source for dashboards and etc. As you can see here, like in the Medium article, we have created a dashboard to track like sales and renting, average rental days for each customer, and you can generate like a bunch of insights for the business stakeholders. Finally, let's just talk a little bit about the budget. I'm not gonna count like the database and the virtual machine that I have in DigitalOcean, because I'm assuming that maybe you have the data source somewhere else. If you want to sum that, you can count and sum there, and also remember that you have here like the link to earn 200 USDs to spend and explore the DigitalOcean services. Here you can see like in the development process we spend $43. That's why sometimes I had to like execute the process several times because it was failing at some point. So we spent a few there, but at the very end and also in the budget folder you could find like the detail of the budget with the current data volume, all of the services, and the details, the location of each service, and then what could be the budget if the data like increase 10 times. Of course, this is an approximate. This could change. This could be more. Maybe sometimes I change the database or something. It could like increase the hours that the cluster is running. Maybe something failed, something is new. You know how this thing works. So yeah, I hope you like it. That's what we have created for you to integrate a lot of services here. So stay tuned for more.